Hello my dear students, in this lecture we are going to see previous year GATE numericals. Basically in this topic we will see latest questions, that is questions asked in GATE 2021 and 20, right? Here in this lecture basically we will see three numericals from the latest GATE examination. Very first question we are going to see is, this question was asked in GATE 2020 in set 2 for 2 mark. The question is on spur gear. Question is, a steel spur pinion has a module M of 1.25 mm. Here module is given for pinion, module is given 1.25 mm. Then 20 teeth. Here number of teeth are given. Therefore T is equal to 20 teeth, right? And 20-degree pressure angle. Here pressure angle phi is given. Phi is equal to 20 degree. Then the pinion rotates at 1200 rpm. Now here speed of pinion is given 1200 rpm, revolution per minute. Then and transmits power to 60 teeth gear, and transmits power to 60 teeth gear. Now here number of teeth on pinion were given 20 and number of teeth on gear are given 60, right? Then the face width F is 50 mm. Here they are saying F is a face width which is nothing but 20 mm. Now here we have to, by default we have to use the same notations as they have mentioned. Then Lewis form factor Y is equal to 0.322. Therefore Y is equal to 0.322. Then and dynamic factor Kv is equal to 1.26. Here dynamic factor, also called dynamic load factor, which is nothing but 1.26. Then the bending stress sigma induced in the tooth can be calculated by using Lewis formula given below. Now here Lewis formula given below, as per this formula, that is sigma is equal to Kv Wt divided by Fmy. By using this formula, Lewis formula, we can find the bending stress. Now again, if the maximum bending stress experienced by the pinion is 400 MPa. Now my dear students, here the stress in pinion is given. So we have to use data of pinion now. Therefore the maximum stress induced is 400 MPa, right? Now the power transmitted is in kilowatt. Now my dear students, here you have to find power in kilowatt. Now they are mentioning round off to the 1 decimal place. Now here the maximum stress formula they have mentioned Kv Wt divided by Fmy, where Wt is a tangential load. Now whatever may be the notation given in the exam, use same notations, right? Here this tangential load generally we represent with Ft, tangential load, right? But use the same notations, right? Don't worry about that. Now my dear students, use this formula. In this formula I think sigma is given, then Kv is also given, somewhere Kv is also given, then Ef is also given, then Em module is also given, and Y is also given. So from this formula you will get tangential load. Therefore use this formula, that is sigma is equal to Kv Wt divided by Fmy. So let us put all the values. Sigma is given 400 MPa, that is Newton per mm square. Kv is given 1.26 into Wt is unknown, divided by F is given 20 mm, module is given 1.25 mm. All dimensions we have to use same units. Y is given 0.322. So my dear students, in this equation only Wt is unknown, that is tangential load. Generally we call it as a Ft in our language. So my dear students, if I simplify for this tangential load, then I will get 6388.89 Newton. This should be the tangential load here, right? And here question is to find power transmitted in kilowatt. So my dear students, let us solve this question for power transmitted. Now my dear students, power is nothing but, here we know that power is nothing but torque into, power is equal to torque into angular velocity, right? That is 2 pi into upon 60. Now torque can be written as tangential force Ft into radius into angular velocity. Therefore here radius into angular velocity is linear velocity. Therefore the power can be written as tangential force into linear velocity. But here for tangential force they have written Wt into linear velocity. And my dear students, linear velocity is nothing but pi dn upon 60. Everyone knows that. Therefore we have to find linear velocity, that is pi dn upon 60. And my dear students, Diameter is nothing but EMT, module times number of teeth. But here, as they are asking for the pinion, right? Here, as this stress value is given for the pinion, therefore let us use the data of pinion, right? Therefore, to find this diameter of pinion will be module into number of teeth on pinion, right? Therefore, diameter of pinion is equal to 1.25 into number of teeth on pinion are 20, right? And if I simplify this, I will get 20. Here, this value will be 25, right or wrong? 25 mm, right? So let us put this here. Let us put this diameter in here, right? Because my dear students, here speed of pinion is given. As the speed of pinion is given, therefore here we have to use all parameters either for pinion or either for gear. This is the basic thing. This is the basic idea. As speed of pinion is given, therefore we have to find diameter of pinion only, right? So my dear students, if I put all the values here, diameter is 25 mm, n is 1200 rpm, right? And eft is we have calculated, so I will get power, but this power we will get in watt, that is watt. The unit of the power will be watt, whatever may be calculated from this formula, but we have to find in kilowatt. They are mentioning find in kilowatt, so let us put the values. So my dear students, this power will be equal to eft into pi dn upon 60. Velocity is pi dn upon 60, but we have to put all values for pinion or gear. We can put for gear also, but speed of gear is not given, pinion is given. Therefore power is equal to ft is 6388.89 into pi into diameter is 25. But my dear students, this diameter is in mm and power is nothing but Newton meter. Watt is nothing but, here let us say, here in simple way I will tell you something, right? Now my dear students, here if I write Newton meter, then it is joule, and Newton meter per second is joule per second, which is nothing but watt. Therefore we have to multiply here diameter with meter, and as this 25 is a mm, therefore I have to multiply here with 10 to the power minus 3, right, to get into meter. Therefore this answer will be in meter. Into n is given 1200 rpm, here n is given 1200 rpm, divided by 60. So if I simplify this, then I will get power is equal to 10,035.64 watt. This will be the power. But my dear students, they are not asking in watt, they are asking in kilowatt. The power they are asking in kilowatt. Therefore we have to divide this 1000, divide this answer by 1000, then I will get power is equal to 10.035 kilowatt. Therefore here if you type 10.035, then you will get full marks. Now the next question was asked in GATE 2019 in set 2 for 1 mark. The question is very simple, straightforward definition they have asked. The question is, the spur gear has pitch circle diameter d and number of teeth t. The circular pitch of the gear is. Now in terms of number of teeth and pitch circle diameter, the circular pitch is nothing but pi d divided by t. That is, here pi d divided by t will be the circular pitch, and we know that d by t is nothing but a module. Therefore it is also written as pi into m module, right? Therefore option A I will see the correct choice. Now the next question was asked in GATE 2020 in set 1 for 1 mark. Again this is a straightforward question that you have to remember. The question is a helical gear. Here helical gear is given. The question is based on the helical gear with 20-degree pressure angle and 30-degree helix angle. Here pressure angle and helix angle are given, mounted at the mid span of shaft that is supported between two bearings at the ends. The nature of stresses induced in the shaft is. Now for helical gear, my dear students, the stresses will be, there will be a bending stress as well as shear stress as well as axial stress, right? In helical gear there will be a bending stress, shear stress as well as axial stress. Therefore look at the option. Now option C, normal stress due to the bending in the one plane. Yes, there is a bending stress. Then axial loading, because of this axial loading there will be axial stress, and shear stress due to torsion. Yes, there is a shear stress due to torsion. Therefore we can say the option C is the correct choice. Thank you dear students. In next lecture we will start new topic.